All right, thanks, Milana. So yeah, like mentioned, the final session today, and we're going to look at the JupyterHub service. Yeah, so it's an interactive service we have here at ECMWF. It's true, it's relatively new, and in the next about an hour, we'll talk about what it is, how it operates, and some practical examples how to use it. Some also service-related nuances, mainly to cover what types of sessions can you launch and what types of resources are available to you. And at the end, similar to my colleagues, we'll try a live demo to show the service more practical. And so I hope that after all this, you'll be more familiar and be able to use it. And so yeah, let's proceed. So a brief overview about what is JupyterHub. Some of you might be already, let's say, professional users, and some of you might not be aware. So let's briefly discuss it and what it is also at the ECMWF. So idea behind the service, it's rather simple. It's to bring together various abilities, basically make it simple for our users to explore and also code and visualize their workflows all in one place and without any need to switch between tools. So everything is already pre-prepared for you. Might be interesting to know that the name Jupyter comes from a blend of three initial coding languages that were supported on the platform, which is Python, Julia, and R. And over time, the concept for Jupyter evolved, and what we have right now at ECMWF is a Jupyter Lab. So it's an ecosystem that sort of brings all these pieces together, giving you infrastructure and also interface to work with that infrastructure. And all of that is available for you through the browser, and you get terminal-like access, but also graphical access to tools that we give our users, also access to extensions, most notably Git integration. And over time, it's become more than just looking at notebooks, but also sort of personal spaces for users that they can use for testing their workflows and also sharing them with their colleagues, and importantly, also for teaching materials. And you can see also a small timeline to display how the service has been evolving here at ECMWF. So it's been around for around 2 years, and you can see some progress has been made during this time. We've constantly added new, let's say, possibilities for our users, and the work is still ongoing. So you can expect further progress in the future. Maybe worth mentioning what JupyterHub is maybe not made for. And it's not made for heavy computing. It's more of a testing workspace. So for heavy computing, you would probably be using just HPC. But for exploration, testing, visuals, and similar tasks, this is a perfect platform. And it's fast, accessible, and a nice place to build prototypes before you would move them into larger work. Yeah, so let's take a look at the next slide. A bit about how the service is built and how you might be experiencing it. So the hub, the JupyterHub that we run, it's sort of a lobby, if you like. So it's a place where you authenticate yourself as a user, and this then takes you to a menu that will define how your work then proceeds. So you will select one of the available backends. This can be dependent on what type of a user you are. but usually these would be either HPC backend, ECS backend, and relatively recent addition is the DSS backends. So if you pick HPC, then your server is running basically through a Slurm job. It's launched through a Slurm job on Atos, and this is most useful for larger memory-intensive work and also longer running tasks. A bit more lightweight is ECS backend. It's faster and a more general purpose environment, and considered ideal for tutorials and also daily work and small to medium workloads. And DSS backends, these are data stores, more more widely known, or basically Copernicus data backends that will bring you closer to Copernicus data, such as atmosphere service and climate service data. Basically, depending on which backend you choose, the selection of the backend depends on what type of data you're interested. So if you would be working with Copernicus data, then most likely you would be running the backend through DSS. While if you're interested more in our data and analyzing that, then probably one of the HPC or ECS backends. It's something that would be useful for you. So what's also worth mentioning is that independent on which backend you choose, the nice part of this service is that your user experience would be the same across all of them. By that I mean the way the service will look on your side will be the same. And what we manage on our side is the login side, is the hub, and on the back side we can develop different type of backends, and this architecture is selected and deployed for us to be easy to maintain it and also to add new backends apart from the already available ones. Might be also worth mentioning that as the service evolves, new backends do become available. DSS backends are the recent ones, and many of our users might also be interested in new backends. And right now, the testing phase is ongoing for GPU integration. Right now, it's also only available for internal users, but as a slight hint, we could be expecting that to become available more broadly in the future. Yes, let's proceed. So for people who've not used it, I will also explain the initial steps, what you need to access the service, and how it also would look on your side when you do. So in the screenshot, you can see the login page. That's where you gain access to further the launcher side of the service. And it's important that before you can launch any of these sessions, there are some quick steps you need to perform on your side to do this. Good news is that you only need to do this once, and then each next time you will just access through login, and then the setup will be reusable. So everything starts with a single sign-on and multi-factor authentication. Once you're logged in, you'll see the more or less familiar Start My Server page. And if you visit it for the first time, the system will generate you a set of SSH keys, and then these you need to also manage on your side. And once you do that, then this key is what allows JupyterHub to talk securely to the compute backends, independent of which, when you're launching your sessions. So you'll need to copy that SSH key into your authorized keys files on the platform. And after that, every next login will be seamless. and you can pick your backend and set your environment variables. A quick thing to mention is that each user only can have one active session at a time. And also each of these sessions has a defined lifetime. For us, it helps to keep the system stable, and also for other users apart from yourself. Basically, this keeps the resources fairly available between all of you. So when you launch a session, you can specify this duration, even though there are some hard limits also. And if you need more time, you can start a new session afterwards. That's also always possible. And yeah, that's it for the initial setup. There's also a link you can see that will take you to the documentation. There's another set of links at the end, but this one specifically instructs users to perform the initial steps to gain access and start using the service for the first time. So once you've authenticated and gained access to the service, this will be the next interface that you're going to see. And I already mentioned this. So this is the place where you select what type of backend or what type of server are you going to launch through for your session. And there are many, more than one available, but this depends, of course, on type of user you are. And basically, it's a drop-down menu which allows you to specify a specific backend that you want to run your session on. And as you can see, there are some other parameters that you can manage. Usually, I'd say for practical tips, we suggest that our users are modest, especially if you're using this for the first time. And maybe don't select the maximum available resources if you don't expect that you will need them. Otherwise, you can also, of course, leave the defaults as is. Yeah, I also mentioned setting the duration for your session. It's sort of a safety timer to prevent any runaway jobs or things that users might forget to close. So we can be sure that nothing is left unattended. One thing also worth discussing while I'm on this slide is that temp directory. So you can manage the size of that, even though, of course, there is a preset for you. And the reason I'm mentioning this is because quite often we see user reports about issues running this service, and very often the issue is actually this temp directory getting full, and then the users cannot perform their work. This is caused mostly by intermediate files being written into it. So you have the option to also increase that when you're launching the session, and quite often that can be a trivial but a simple thing to manage on your side to avoid any such issues. From other things you can select here, it's the version. Usually then you'd also rely on the default, unless you particularly know that that the work you've been doing previously sort of relies on an earlier version of the service, then you could also specify that. Finally, there's also this debug window you can see here, which we have there particularly for times when there's some issues starting the service. So you can select this to enable it, and this will give you a log on the launch, basically instructing you more or less in human language about the issue, why a session fails to start. And so this is useful both on your side, but also when you're reaching out to us about an issue. It's helpful to see any such logs to try and reproduce the issue and then help our users to fix them. Okay, let's proceed. So once you've launched the session, this is this is how the service would look. It's just one of just a print screen from it. But basically, you will get access to a launcher menu, and from there you can then launch different type of services and also terminals that you might want to use. It's sort of your home base. Everything starts from here. On the left side, you can see there's also some tabs. We'll look at these in the live demo. It actually offers quite a lot of functionality already built in. Some of it less hidden, some of it more, but very useful for different types of purposes. But we can look at that during the demo side. What's important here as well, yeah, you can manage extensions, and this left sidebar is mostly used also for managing files, modules, and to basically make sure that your work runs as you expect it to. Moving on, then what software stacks, basically modules and kernels. It's a relatively important topic. So when you start a kernel, it sort of captures at the instant or the environment that exists at that moment, and that means that anything you do afterwards, particularly loading modules, paths, and variables, it's not immediately saved. So you would need to also tell the kernel that something has changed. So that's why when you load a new model, for example, after you started the session and the kernel, nothing inside would immediately change. And this means that the kernel is still running inside the original snapshot, and simply it does not see any changes for your new environment. So it's a simple rule of thumb. So after you load modules, you would then need to restart your kernel, sort of to tell the system that something has changed, and make a new snapshot of your session, and then what you've loaded and the variables you've set, the modules you've loaded and the variables you've set now become available for you. And this restarting refreshes everything and puts it into scope. Let's tell it like that. And similarly, same thinking can apply to Conda environments. So when you create your own, it's worth keeping a clean record, sort of a file that describes what's installed. And then once you run that installation, you again need to tell the kernel that something has changed and you need a new snapshot to run this cleanly. And some of course, everything of this is documented also in our knowledge base, but simple, let's say, commands that are most useful, you can see also on the slide here. Can be useful also. The final one is when something is not no longer needed for you, you can also remove those and then also restart your kernel to make that the new reality, let's call it like that. Another important thing to manage for yourself is the storage and some best practices that we usually offer. So when you log in, you'll always land in your home directory. It's a small directory, it's backed up, and ideal for storing notebooks and configurations, and also some light work that you might have, but not best for some heavier data compute. And for that, then we have other places. These were already spoken about by my colleagues previously, but just to briefly go over them, then Perm, it's the space for results or storing your results, and it's a long-term storage, so you can be sure that things you stored there will not disappear. And this is where we suggest that you keep data and artifacts that you want to preserve for a long time and share also with other users. The same logic applies to HPC Perm, so it's a nuance how you call them. And then a bit different, Scratch directory, it's more or less the opposite. So it's high capacity but temporary area designed for intermediate files. So some outputs that you want to process, but you don't really need, and you're fine with cleaning them up later on. Interestingly, also to mention is that when you do land in a JupyterHub session, of course, you see the file tree as usual, but a very useful thing to do when you're using JupyterHub is to add these shortcuts or symlinks to your home to basically easily take you to these storage locations. And this is done by simple commands to add these symlinks to your home directory. And then once you've done that, you can also favorite them so that they always appear on your main screen when you launch a session. Quite useful, and we'll also take a look at in the demo how it looks and how you can manage these. Moving on then, almost closing in on the presentation side, but we can briefly go through the common issues that we see on our side from user support perspective. So the first one is session timeouts. I already mentioned about these Jupyter sessions being time constrained. So every session will end exactly when it's scheduled to, and that is by design, and it's not random. So if you're deep in a notebook when the clock runs out, and the server will run out. So we do suggest that you plan the duration of your work that you're doing, and always save important data to either perm or HPC perm side before any session would expire, so you don't lose any data. The second one I already mentioned, but just to reiterate, it's no space left on device message. It's a classic we also see on our side, and almost all of these cases are resolved by managing the size of temp directory or the way the files are written there. So, and then the final issue that's worth mentioning here is startup failures. These can be caused by a variety of issues, but whatever an issue is appearing, we suggest that you simply set the debug flag before launching the session, so you can read the log, and you can also seek further support by sharing the log with us. You're always welcome to reach out to us through the ticket service that we offer. And then when you do, the more evidence you give us, the easier it is for us to understand, reproduce, and find a solution for you. To close up on this brief introduction, then some links. This is the login page that I will show you in a second. Also the JupyterHub knowledge base page, and also I already mentioned the ticket service that we have for opening issues and reaching out to us. So from practical side, I think I would stop here and maybe try and also do a live demo for you to sort of ground some of the things that I spoke about previously. So yeah, for questions, of course, you can ask directly right now, but you're also welcome to put them in the chat. I will meanwhile try to switch my screen to the other one. So I'm assuming that you see my screen. So this is the homepage for starting the server. One before this one, we can also start from 0. It's the sign-in page. So need to authenticate here. Of course, you also get a nice banner here telling about any expected sessions on service side that might impact your work. Nice information for you sometimes to plan and also to get immediate answers why something might not be working. Always worth checking here. The status page was also mentioned before, so it's another place you can get familiar with ongoing activities for maintenance. Afterwards, you would sign in. And now we come to the page where we can select what type of server we are going to launch. As I mentioned earlier, the selection here will depend on the type of user you are, so there's more than one, but ECS is most widely available, so I'm going to launch a session through that one. For the menu items, you see further for configuration. These are clickable, just to briefly show you, but I will launch probably a default one. The type, the available memory, you can select the computing CPUs, duration of the session, so you can actually have them quite long if you like, but I consider myself long for up to 7 days. The temp directory size can also be managed. These 3 gigabytes can fill up quickly if you're doing some intermediate processing. Also the version selection and the debug. So I'll set the debug for yes this time, so we see if anything happens. We can also see that log, but everything else I will leave as is for now. Then we'll start a session. And we need to wait a bit. We can look at how the session is launching. And we need to wait a tiny bit. This is a live demo. Stick with me, please. You can see, for example, the node, which is gonna run the server. These change. Previously, my colleagues also spoke about these different nodes that we have on HPC side. And we're almost there. So now that we're in, this is how the session looks once it's launched. This is the usual first menu that you will see. It's called the launcher. From here you can select different type of consoles and bash terminals and system terminals that you can run. Briefly, we can also look at what else is available. So on the left side here, we have the file browser tab. You can see I already added some symlinks, but before these are added, this place would be empty before we can take a brief look how to add and remove these afterwards. And you would usually see your home directory under here. I've already moved into a demo folder that I created for this tutorial, not to confuse you with my own files. Yours will look a bit different. Besides the file directory, we also have place where we can check the kernels that are running. Currently nothing is running, so it's empty. You can check the open tabs that you have and various other sometimes useful information that you can click through. So next one, also quite useful, is the Git integration that we have in the service. So you can, of course, clone a repo also through command line, but we also offer a graphical means to do this. By graphical, I mean that you click a button and you still need to provide the location of the repo. And also worth mentioning that during this demo, I will mostly be sticking to the graphical interface here rather than command line. What else? Table of contents. This can be useful when you're working with notebooks in particular. So when you have large notebooks, this can be helpful to navigate through them instead of going through the whole notebook. You can just go through the headings. You can also manage PyPy packages and see what's installed and also find new ones. And finally is the module manager. So this will help you graphically also to find and load modules that we offer to our users directly. Yeah, on the right side, there's also some tabs, property tabs, kernel management tab, and also debugging tab. You can, of course, inspect these in more detail once you use the service. Something else worth maybe quickly looking at is you can also manage how these sessions look for you, the layout of the service. And for example, recently we've added also these dark themes for the service. Some users like these, so you can manage even nuances like that. So I already mentioned previously, but when you look at the file tree, you can see I already added these symbolic links or symlinks here, but you can manage these on your side as well by adding them. If you look at the documentation, I already have this page open. It's a simple thing to do, and you can do this on your side as well. But basically, you define the location of that link, and then you add it to your file tree. After it's there, it will first appear in the file browser, and then you can put it as your favorite, and then it's stored here on top, just as you see on my session here. So probably the next thing we can do is something a bit more interactive, and this would be trying to clone and look into a repo, and also how to manage modules that are needed for running a notebook inside that has some dependencies. So I'll clone a repo here for this test. I'm going to look at the Matthew examples. As you can see, I already tested this before, so I have the link here, but these links I can share with you afterwards as well. It's going to be a repo containing Matthew Python examples. So let's clone that and wait a moment until it loads. So we have it now. I think I cloned it in Parm, which I did not want to do. So live demos. Okay, so I cloned the repo. This is this repository that we have here on Git. You can inspect it yourself as well. But the idea here is that I will show you some notebook that we can run here, and the point you'll see later on is also how to manage software modules. So let's try and run this notebook cell by cell. If you click this play button on top, you can see I'm moving right now through the markdown cells that are describing the notebook. But the next one, this one, is finally a code cell. So in this one, we need to import a particular software library, which is called NetView, which will then be later used in the notebook. So let's try and run it. And expectedly we come to an issue where the module is not found. And so to manage this, I'm going to stick again to the graphical approach. We're going to go to the package manager modules, and I need to find the ECMWF toolbox. So this module includes, let's say, the most used packages that we have here at ECMWF. If you type here just for searching something, then immediately you will get results. And as you can see, there's more than one available module here. And after the slash, you can see that's the the version, the release date. And so we'll select the latest one and just we can inspect it a bit, what's inside of it. But to save on time, we'll just load it. And now we have it. We see it. It's now part of our loaded modules. So let's try and run the code cell again. But you see it fails again. And this, I'm trying to build a point here. The point here is that the kernel does not yet know that we have it. And so to do what we need to do is now to restart the kernel. And let's maybe also try opening the notebook again. And let's get to that code cell. Live demo.
You can't just close it. You have to do shutdown kernel.
Yeah. Okay.
I'll try.
Yeah. Thanks, Milana. So finally, yeah, this was resolved, as Milana pointed out, not just closing it, but also making sure the kernel stops and then gets started again. So that resolved our import error previously. Now we see that the software is imported and found, which now means that we can also successfully run the next cells. In this repo, the files are already available, so we're not downloading anything. It's just running off the file in the repo. And therefore, apart from Matthew dependency, there's none other here. For more, let's say, complex notebooks, there might be more than one. So you have to make sure that you load the correct modules before you do your work. Yeah, and then everything else should run smoothly. I'm not sure if we should click through all of this. Probably not. You can do that on your own time. This is not the point also of the presentation. And I guess I'm coming to a close here. So what's also worth sort of a hygiene task is when you're done with your work, it's also suggested that you manage this. You can go to the hub control panel here, which will take you back to this sort of starting page. And from here, you can stop your server. So any session you have is not left running without purpose on our side. And you just click the stop server button, and that will close it. I think that's it from my side. Yes.
Thank you very much, Valters.